So you want to learn about covalent bonds. First, we have to look at what's the difference between ionic and covalent. Well, ionic transfers electrons, covalent shares them. Ionic is a bond between a metal and a nonmetal. A covalent bond is between two nonmetals. Ionic bonds are held together by the attraction of a positive and a negative charge or charges. And covalent bonds are held together by the sharing of the electrons. So an ionic bond, again, they are not shared, but one takes the other electrons. And a covalent bond, they actually share them like these guinea pigs are sharing the carrot. Covalent bonds, again, they're sharing it. So in a covalent bond, we are looking at the Lewis dot structures again. Here's fluorine and fluorine. When we add them together, they look like this. Those two electrons are sharing so that this has two here and this has two here. But we don't show it in that way. What we do is we show it with a line. So it's like it's sharing a set of two. That is a single bond right there. So we've got the unshared pairs around the outside, and then the shared ones are in the middle. That, again, was a single covalent bond. Two atoms are held together by sharing a single pair of electrons. So here we're showing hydrogen and hydrogen, and when they bond, okay, hydrogen has one electron in the valence electron, and hydrogen has one valence electron, so they bond so that they have two. Hydrogen has a full energy level with just two electrons because the energy level in that first circle of electrons, there's only two in there. So that's stable now. Okay, a double covalent bond. That's a bond that involves two shared pairs of electrons. So oxygen plus oxygen. Remember, they have 6 valence electrons each. And now how do we share them? Well, they're going to share those. So it will end up looking like this. We've got 2 being shared here, 2 being shared here. So that's like 1, 2, 3, 4, 5, 6, 7, 8 for this one. 1, 2, 3, 4, 5, 6, 7, 8. That's what we want. Okay, so here's a single bond showing 2 electrons are shared. Here's a double bond showing 4 of them are shared. Here's a triple bond showing there's 3 double bonds there. 3, electron pairs being shared. Okay, so now let's do one that's a little tougher. Here's carbon bonding with 2 oxygen atoms. So we put the carbon in the middle, put the oxygen on the outside, put their valence electrons in there, and then we go, okay, how are we going to share them so that this one will add up to 8, this will add up to 8, and these will add up to 8? Well, if we share that, and we share those, and we share those, and we share those, then we have 8, 1, 2, 3, 4, 5, 6, 7, 8 for the carbon, and then 1, 2, 3, 4, 5, 6, 7, 8 for the oxygen, and again 8 over here, making them all